Welcome to determining when expressions are undefined. A fraction or a rational expression is undefined when the denominator is equal to 0. We know that, right? You can't have 1 over 0 because it's undefined. Now, the x values that make the denominator equal to 0 are known as excluded values. We want to exclude them from the x values that we can possibly plug into the equation because they make your denominator 0. So for the following examples, we're going to find the values that make the following expressions undefined. In other words, we're going to look for when the denominator is equal to 0. So the first one, if you have 1 over x, you can have 1 over 2, 1 over 3, 1 over 4. What you can't have is 1 over 0. You literally take the denominator and set it equal to 0. The only difference is that we don't want x to be 0 because 1 over 0 doesn't exist, right? It's undefined. So we're going to say that x can't equal 0. X could be any other number. The next one, you're going to do the same thing. You want to find which value of x makes your denominator equal to 0. So x minus 2 equals 0, and you're going to solve for x. But again, we don't want x to equal 2 because that makes our denominator be equal to 0. And that's not good. So we want to say that x does not equal 2. X can be any other value. If you have a more complicated expression like this one here, first of all, we're going to ignore the numerator because that has nothing to do with it being undefined. We're going to take the denominator and set it equal to 0. And we know how to solve this, right? You factor it with the AM method. So you want to find two numbers that multiply to negative 24 and add to positive 2. Those two numbers are going to be plus 6 and minus 4. Because 6 times negative 4 is negative 24. 6 minus 4 is 2. And to solve this, we're going to make a t-chart. And you get that x is equal to negative 6 and x is equal to positive 4. But remember, these are values that make it undefined, so we do not want x to equal these two values. So anytime you're trying to find when something is undefined, take the denominator, factor it if you have to, and solve for when it equals 0. Last problem, those were all expressions before, and now we have an equation. And it actually, undefined values, excluded values, it changes how your equation is going to look. So for example, this one is going to look something like this. And something really funny happens right here. Can you guess what x value that's going to happen at? If you look at where your function is undefined, and if you solve for these excluded values, you get that x can't equal negative 4. That's why at negative 4 on the graph, something's funny going on. Because your graph literally can't touch negative 4. You can't plug it in. It's undefined. There is nothing there on your graph. In fact, if you were to look at this on the table, on your calculator, you'll see when x is negative 4, your calculator is going to tell you that there's an error there because you have an excluded value.